Okay, here's a thought. What if your computer could do more than just follow instructions? I mean, what if it could actually look at what you told it to do and find a better, smarter, faster way to do it, all on its own? Well, that's the huge shift we're digging into today in our database history series. We are talking about the AI supercompiler. This is the moment when our workflows started to rewrite themselves.
For most of computing history, the deal was pretty simple. We, the humans, were the architects. We designed everything, the code, the algorithms, every single step the machine was supposed to take. The computer was this incredibly powerful tool, for sure, but at the end of the day, it was an obedient servant. It did what it was told.
But what happens when that relationship fundamentally changes? What if the servant starts becoming a collaborator? Well, that's pretty much what happened around 2027. That year marks this massive turning point. It was the year a whole new layer got added to the AI operating system, and suddenly the machine started rewriting the rules, literally. Now, to really get why this is such a revolution, you gotta go back and look at the old world. This was an era where every single process was basically handcrafted by human minds. It was painstaking work. Think about it. We were the ones building these complex scripts and pipelines. If something was slow, it was on us to find the bottleneck. If a process was fragile, we had to go in and rewrite it. The entire burden of making things work, and work well, it all rested on our shoulders. The machine it just followed the map we drew, even if that map took it through the scenic route every single time. And this quote just hits the nail on the head. The machine was kind of like a virtuoso musician who could play any sheet music you put in front of it perfectly, but couldn't compose a single original note. It was a follower, never a creator. It simply couldn't learn. And then everything changed. The AI operating system showed up, and with it came this absolute tidal wave of complexity that just shattered the old way of doing things. That simple, predictable, one node at a time process, it was gone, replaced by a symphony of what you could almost call beautiful chaos. All of a sudden, everything was happening all at once. The best way to picture it is to imagine a giant chaotic kitchen. You've got dozens of agents, or chefs, all running in parallel. Tools are firing off whenever they need to. The pantry, the semantic RAM, is being restocked and reorganized in real time. And in the middle of it all, the head chef, the kernel, is just desperately trying to schedule and verify every single thing that's happening. So workflows weren't these static, straight lines anymore. They became living systems. They were constantly changing, adapting, and reacting to new information. And while this was an incredible leap in capability, it also created a massive, massive problem. And here's the bottom line. The system just got too complex for us to handle. Its complexity totally outpaced our ability to manage it. You couldn't just pop open the hood and find the one broken part anymore. The problem was everywhere and nowhere all at once. The AIOS needed its own immune system. And that's exactly where the AI supercompiler comes into the story. The system needed a way to diagnose and redesign itself from the inside out. That solution was the supercompiler. So the supercompiler isn't actually part of the core execution engine. It's better to think of it like a silent observer, kind of like a guardian angel watching over the whole system. It sits just above the kernel, and its one and only job is to watch everything, measure everything, and then rewrite the entire workflow to be as efficient as it can possibly be. And once you add this layer, the whole nature of the system just transforms. It's not a static machine anymore. It becomes this living, breathing organism that's actively learning from its own behavior to get better. The AIOS starts to optimize itself. So the big question is, how does it actually do this? Well, the process is this constant, really elegant three-step dance. Observe, analyze, and then rewrite. Let's break down how that actually works. Okay, so first it observes. It's like a hawk circling high above, watching every single agent, logging every single tool call, and measuring everything from latency to wasted effort. Then it analyzes all that data. It's like a detective sifting through clues, looking for patterns, finding those duplicate steps or inefficient sequences. And finally, based on that analysis, it rewrites. It acts like a master architect, generating and deploying a brand new, totally optimized workflow. And the results are, well, they're pretty incredible. You can see it here. Where it found duplicate steps, it rewrites the process to have fewer steps. Where it found agents grabbing data they didn't need, it just cuts out those queries. And maybe most importantly, where it sees tasks happening one after another, it rewrites them to happen in parallel, like a conductor leading a 100-piece orchestra all at once. This analogy is a good starting point, right? But it's actually even deeper than that. It's not just about rewriting the recipe to be faster. It's more like the chef is inventing a whole new way to cook, a kind of culinary logic that no human chef would have ever thought of. And that is where this whole thing gets really, really interesting, because the workflows that the supercompiler creates, they don't look anything like something a human would design. People started calling them machine-native workflows. And like the definition here says, they are not built for human intuition or readability. They are built for one thing and one thing only: pure maximum machine efficiency. They can look pretty alien to us. I mean, these workflows operate on a completely different plane. They use levels of parallelism that our brains just can't track. They find these clever, non-obvious shortcuts to reuse information from memory, kind of like a chess grandmaster seeing a dozen moves ahead. They even restructure entire tasks around the underlying meaning of the goal, not just the step-by-step instructions they were given. And really, this is the big takeaway. The supercompiler is the point in history where AI stops being just a parrot, brilliantly mimicking our logic but faster. It becomes a creator. It starts discovering and inventing a new, more efficient logic all on its own. But this new, powerful machine logic doesn't just run wild. The whole system is designed with this crucial partnership at its core, one that ensures both safety and efficiency. It's a really delicate balance of power between two key layers. This table really lays it out perfectly. The kernel is still the ultimate guardian. It's the unshakable foundation that enforces truth, safety, permissions, all the hard boundaries. It's the ground rules. The supercompiler, on the other hand, is the optimizer, working within those rules, completely focused on making things efficient and well-structured. So the kernel provides the guardrails, and the supercompiler is finding the absolute fastest way to get from A to B inside those rails. And together, they form this perfect partnership, a kind of yin and yang of control and creativity. What you end up with is a system that learns not just from external data, but from its own internal behavior, getting smarter and more efficient every single time it runs. And that, right there, is the moment AI really became self-aware, at least in terms of its own performance. So what's next? What other chapters of database history are out there just waiting to be told? That's where you come in. Let us know in the comments what part of computing history we should dive into next. Thanks for watching.